Nice, we have a Kepler's law question here. This links nicely to circular motion, lots of stuff, good stuff here. So as ever, SLHL, please try this one, and when you're ready to see an answer, press play. Okay, so like I say, I think this is one of these ones that you may just memorize Kepler's laws, or you might want to derive them. What we're going to do here is I'm going to tell you the answer. The answer here is A. Okay, we're then going to derive that. Okay, because this comes from circular motion. We have the idea that the centripetal force is provided by the gravitational force. We're going to go for m omega squared r. We've done this a few times, so if you need to skip this, feel free. Equal gmm over r squared. Those m's are going to cancel. And we're going to rearrange so that omega squared r cubed equals gm. We can then substitute omega equal to 2 pi over t to get our equation r cubed over t squared there, which is why we've got then r cubed equal to some constant times t squared. And that's exactly what we've got here. Well, I've rearranged it in a slightly different way. We've got a square of the orbital period, that's t squared, going with the cube of the length, that's r. So that's why we've got this answer here, A. Remember, Kepler actually made this without really applying the ideas of circular motion. However, it turns out our circular motion is a good approximation for this elliptical orbit. Now, what we'll do here now is have a quick look at B, C, and D and sort of see what is wrong with those. Okay, B is very similar to one of the laws. This is the second law. Okay, so this is the third law. A is the third law. B, second law there, says line segment joining a planet sweeps out equal arc lengths. I'd like that, however, actually it sweeps out equal areas. So if you wanted to write down Kepler's laws, the second law would be this. However, getting rid of this arc length and changing it for areas would work. We've got a planet's orbital period is proportional to the cube of the length. Okay, that's not true because we want t squared going with this. And then last one here, orbit of a planet is an ellipse with the sun positioned at one of its foci. Okay, so which is slightly different to the center. Remember, we're dealing with elliptical orbits here. I was trying to think, just as I was speaking there, about how you know that A is one of the answers. Well, if you notice here, A and C are very, very similar. Okay, and sometimes you might go, well, look, they're making two statements here. Clearly, one of these is wrong because these two cannot be true at the same time. So again, in your exam, you're pushed for time. You don't know exactly what's going on. Then one thing might be to just read those statements and go, okay, which two are contradicting each other? It's very likely one of them is going to be right and one of them is wrong. And then in this case, the answer here is A.